Good morning, everyone. This is Dharma. The subject is Design of Machine Elements. My roll number is 20951 A0314. Today's topic is Global Modeling and Control Strategy Simulation. I am from Mechanical Branch. Abstract. This introductory tutorial is overview of simulation modeling and analysis. The intended audience in those unfamiliar with the area of discrete event simulations as well as beginner looking for an overview of the area. This includes anyone who is involved in system beginning, design and modification, system analysis, management, personnel, engineers, military players, economy system, banking analysis, and computer scientist. The familiarity, the probability and statistics is assumed. What is modeling? Modeling is a process of producing a model. A model is a presentation of concentration and working of some system of interest. A model is a similar to but the simpler than the system it represents. One purpose of model is to enable the analysis to predict the effect of changes to the system. On the one hand, a model should be close approximation to the real system and incorporate most of its should be silent features. On the other hand, it should not be so complex that it is impossible to understand and experiment with it. A good model is a judicious trade-off between realism and simplicity. The simulation practitioners recommended increasing the complexity of a model. Iteratively, an important issue in a modeling is model variability. Model verification techniques include simulating the model under known input conditions and comparing model output with the system output. What is simulation? A simulation of a system is the operation of a model of the system. The model can be configured and experimented with. Usually, this is impossible to expensive or impartial to do in the system it represents. The operation of model can be studied and hence properties cornering the behavior of actual system or its subsystem can be inferred. In its broadcast sense, simulation is a tool to evaluate the performance of a system, existing or proposed under different configurations of interest and over long periods of real time. Simulation is used before an existing system is altered or a new system built to reduce the chances of failure to meet specifications, to eliminate unforeseen blockades, to prevent under over the utilization of resources, and to optimize system performance. How to develop a simulation model? Simulation model consists of following components: system intangibles, input variables, performance measures, and functional relationships. For instance, in a simulation model of M-M-1, unique. The server and the unique are the system intents. Arrival rate and service rate are input variables. Mean wait time and maximum unique length are performance measures, and time in system is equals to wait time plus service time. An example of a functional relationship: almost all simulation softwares package provide constructs to model each of above components. Modeling is arguably the most important part of a simulation study. Indeed, a simulation study is as good as a simulation model. How to design a simulation experiment? A simulation experiment is a test or a series of tests in which meaningful changes are made to the input variables of simulation model so that we may observe and identify the reasons for changes in the performance measures. The number of experiments in a simulation study is greater than 1 equal to the number of questions being asked about the model. Example: is there a significant difference between the mean delay in communication networks A and B? Which network has the least delay, A or B or C? How will in, how will a new routing algorithm affect the performance of B network? Design a simulation experiment involves answering the questions: what data needed to obtain, in what form, and how much. The following steps illustrate the process of designing a simulation experiment. What makes a problem suitable for simulation modeling and analysis? In general, whenever there is a need to model and analysis randomness in a system, simulation is tool of choice. More specifically, situations in which simulation modeling and analysis is used include the following. It is impossible or extremely expensive to observe certain processes in real world. Example: next year's cancer statistics perform of the next expense to observe the next schedule and the effect of internet advertising a company's sales. Problems in which the mathematically model can be for muted but analytic solutions are either impossible. Example: job shop scheduling for problem, higher order difference equation are too complicated. Example: complex systems like the stock market and large scale economic models. It is impossible or extremely expensive to validate the mathematically model describing the system. Example: due to insufficient data. What are some pitfalls to grade against in simulations? Simulations can be a time consuming and complex experiences, from modeling through output analysis that necessitates the involvement of resident experts and decision makers in the entire process. Following a checklist of pitfalls to guard against. Nuclear objective. Using simulations when an analytic solution is appropriate. Invalid model. Simulation model too complex or too simple. Erroneous assumptions. Undocumented assumptions. This is extremely important and it is strongly suggested that assumptions made at each stage of simulation modeling and analysis experiences be decommunicated thoroughly. Thank you. Thank you for giving this wonderful opportunity to share my views. Thank you, one and all.